All right, another way you can use the mean, the meta of the data set, and the standard deviation, how the data is spread out, okay, is to identify which of these data values of your data set. So I have 17 test scores here. I want to find out which of these test scores are typical or usual, or not typical, or sometimes also called unusual. And the way we do that is, again, using this bell-shaped curve. Just to review again how this bell-shaped curve came. I did a number line and I put a mark in the middle. The mark in the middle is always the mean, mu. Okay, and then I put 3 marks to the right, 3 marks to the left, and I need to label those marks. The way I label those marks is was using the standard deviation, in this case 9. So from the middle I start counting 9 to the right. That's how I got these numbers. And from the middle I counted by 9 to the left. That's how I got these numbers. And we have a more accurate, precise bell-shaped curve than the histogram. And I can start getting extra or detailed information that helps me make informed decisions. One of them is what I said. I want to identify which of these data are typical, also known usual, or not typical, also known as unusual. And what you do is start from the middle, the mean, and count 2 standard deviation to the right. So since my standard deviation is 9, I'm going to count by 9 twice to the right. So I ended in 92. So anything that is 92 or more, okay, we consider that unusual. Okay, how did I get the 92? I counted 2 standard deviation to the right of the middle. I counted by 2 9s to the right. So 92 is 2 standard deviation from the 74. I'm going to do the same thing to the left. Start in the middle, count by 2 9s to the left. So I ended on 56. So 56 is 2 standard deviation to the left. That's what -2 sigma means. And any data that is 56 or less, okay, that will be also considered unusual. Okay, now what happened with the middle? What do we consider all of these numbers in the middle between the 56 and 92? We consider those usual. Okay, so a student who got a test score that was 92 or more, that student is that score, I should say, is unusual. It's not typical. Why? Because you can see that anything that is 92 or more is around the tail. And what that means that not so many students got those scores. Okay, when you're in the tails, that means the least amount of the data set is there. And the same thing happened. Any student who got a 56 or less, okay, that test score is unusual. That's rare. Okay, again, you can see that anything that is 56 to the left is around the tail. That's where the least amount of data from these 17s is located. Most of the data is in the belly, and the belly is between 56 and 92, not including 56 and 92. Okay, and that's what we call usual, typical, common, normal. Okay, and that's how we can use the mean and the standard deviation to figure out what is the typical and not typical data value from the set.